Have you found a pattern yet? The next number that would come in this pattern is 36. And then 49. 64. These are what we call perfect squares. This number right here is 1 squared. This number is 2 squared. This one is 3 squared, 4 squared, 5 squared, and then it would be 6 squared, 7 squared, 8 squared, and so on. In lesson 3.1, you are going to find square roots of perfect squares. Perfect squares are 1, 4, 9, 16, 25, and 36. Those are perfect squares because they are the squares of integers. Squaring a number and taking the square root are inverse operations. The square root is one of the two equal factors of a number. So, like the square root of 4 is 2, the square root of 9 is 3, square root of 16 is 4, and so on. And the radical sign that looks like this is used to indicate the positive square root, because actually when you take the square root of a number, there's actually 2 square roots, because the square root of 4 could be 2, or it could also be -2, because -2 times -2 is also positive 4. But when we use the radical sign here, it's used to indicate the positive square root. All right, in our first example, we're asked to find the square root of 64. What number times itself gives you 64? Well, the number multiplied by itself to give you 64 is 8. Now in example 2, since we put the negative sign out in front here, that indicates that we want the negative square root of 25/36. So we want to know what number times itself gives us 25/36. Well, another way to write the same number would be like this. 5/6 times 5/6. Oh, what happened there? Computer's doing funny things. 5/6 times 5/6 is 25/36. So if I took the square root of this, I want one of two equal factors, so it's going to be this right here. And because we have the negative in front, we want the answer to be a -5/6. Now in example 3, this out front indicates that we want both the positive and the negative square root of 1 and 21/100ths. So our final answer is going to be both the positive and the negative. And we have to figure out what number times itself is going to give us 1.21. Well, if I think of this number without the decimal point, I have 121. And I know that 11 times 11 is 121. So now I just would need to figure out where I would need to put the decimal in my number so I get the decimal point right there in my answer. I would want the decimal point to be right there, because remember when you multiply decimals, you add up how many numbers are after the decimal in the problem, and that's how many numbers should be after the decimal in your answer. So for this particular problem, the square root of 1 and 21/100ths is going to be 1 and 1/10. And it's going to be positive or negative 1 and 1/10 since it has that plus or minus sign in front. You may want to pause the video and try the next 3 on your own. For the first example here, We're going to want the positive square root because we just have the radical symbol. And I have to think about what number times itself is going to give us 9/16. Well, this would really be 3/4 times 3/4 because 3 times 3 is 9 and 4 times 4 is 16. Basically, we're going to take the square root of 9 and the square root of 16. And it's going to be positive 3/4. Now in our next example, we have a negative sign in front of it, so we're going to want the negative square root of 49. Well, what two numbers multiply together to give you 49? It would be 7 and 7. So -7 is the square root of the negative square root of 49. And now our last one, we're going to want both the positive and negative square root on this one. Remember I said think about this number without the decimal point. Without the decimal is 81, so it's going to be 9 times 9 gives us 81. But in order to get the decimal point here, I would have to have the decimal right there in my numbers because that would be a total of 2 places after the decimal for the answer. So it's going to be plus or minus 9/10. Actually, I'm going to put a 0 in front of the decimal point. Now the next thing we're going to do is use square roots to solve an equation. So it says solve t squared equals 169. Well, just like in our previous equation solving, we want to draw train tracks and we want to undo what's been done to the variable. Right now the variable's been squared. To undo squaring, you want to take the square root. If I take the square root of t squared, I get just t, and the square root of 169 is 13, but it could also be -13. So we're going to say 13 or -13. You want to pause the video and try the next two on your own. 289 equals a squared. You're going to want to take the square root of both sides. The square root of a squared is just a, and the square root of 289 is 17, and it could be positive or -17, so plus or minus 17. So a equals plus or minus 17. In our next example, draw your train tracks. Take the square root of both sides. Square root of m squared is m, and the square root of 9/100. Again, when it's a decimal like that, think of it as a whole number. Square root of 9 is 3. Now, where would we have to put the decimal point in our problem to get 0.09 as our answer? We'd want to put the decimal right there because then we'd have 2 numbers after the decimal, and our answer has 2 numbers after the decimal. So it's going to be plus or minus 3/10. One last example. A concert crew needs to set up 900 chairs on the floor level. If the chairs are placed in a square arrangement, how many should be in each row? Well, if it's in a square, the length and width are going to be the same. Or the side times the side, or the side squared, it's going to have to equal an area of 900 chairs. So the equation that we're going to solve is s times s, or s squared, equals 900. Draw your train tracks. Undo the squaring by taking the square root of both sides. square root of s squared is just s, and the square root of 900 is 30. Now this time I wouldn't want to put the negative square root. I wouldn't want to put negative 30 because it wouldn't make sense to have a negative 30 chairs in each row. So we have a positive 30 chairs in each row.